Industry 4.0 is for some of us. And in terms of, what is the core? What is at the core of Industry 4.0? So I would say communication, collaboration, effective decision-making, improved productivity, and people. So by communication, I mean, increase in communication has made it possible for us to be able to have software that can basically understand several languages. So that means I can be working with somebody in China and I don't need to learn Chinese, because there's a software that, can be translating things to me almost real time. And in the next few years, you will actually be able to have conversation with people seamlessly without having to learn a language. And many other things, including the use of mobile phone, which is really helping us now. Thanks to Zoom and other technology, even though we are kind of locked down in a way, we are still able to communicate, we are still able to have this seminar, right? So these are things that are driving the whole agenda of Industry 4.0. The other one is collaboration, of course. No one is an island. You can't do this, everything by yourself. So you need different people from different aspects of the society, different sectors, and you want to collaborate with them. We want to be able to make decisions quickly. We want to improve productivity. But the most important of this really are the people. Because in the end, yes, it is true, robots is going to be the one doing some of this job because they don't have emotion and they don't have to sleep, while we can go partying and go looking after our children and the rest. But actually somebody needs to program the robot. And when it gets damaged, someone needs to restore it, repair it, and so on and so forth. So that is why we need people. People is actually at the heart of everything that we're talking about. Okay, so stats, a bit of statistics here. So Industry 4.0, it says could add $14 trillion to global economy by 2030. 67% of UK manufacturers recognize Industry 4.0 as an opportunity. 28 billion is the amount expected cost reduction in the automotive sector alone between 2016 and 2020. That is if they go fully into Industry 4.0. Now we're doing a number of projects with them already. About 30% increase in productivity is expected when you have Internet of Things connected in your factory. Reduction in costs, about 3.8%, and so on and so forth. However, companies are still struggling. About 25% of the manufacturers feel that they have a sufficient understanding of Industry 4.0. Only 25%. So there's still 75% that don't even know what it's about. And there are many of them that don't know what they can benefit from it. And even more importantly, they do not have the skills to make this happen. And this is where we come into all this. Engineers, academics, everyone working together. So really what I want to present to you in the next few minutes, and I'm aware of my time as well, is basically how we at Manchester Met, we're kind of doing this. And the picture I want to paint really is to let everyone see how they contribute to this. We are all stakeholders in this. The industry, academic, the government, everyone involved in it. And charitable organization like NSE as well. So these are, this is just statistic, a percentage of organizations that acknowledge that digital talent is widely, meaning that actually the gap is so wide now from those who know and those who do not. So that gap is really wide. So we need to fill the gap as soon as possible. So at MMU, what we did actually is we look at the 9 pillars of Industry 4.0. And the 9 pillars are what you have in front of you there: additive manufacturing, big data analytic, which, AI, machine learning, deep learning also, and so on. Cybersecurity, autonomous robots, simulation, integration, Internet of Things, the cloud, augmented reality, and so on. And all these 9, we then started forming group of researchers, and then they started working with industrial partners So
in the university, it's not just about teaching and learning, but also about research. Now, you may ask yourself, what exactly is research? Research is essentially moving the frontiers of knowledge. How do we question? We may have a question which has already been answered, but then we may not be satisfied with the answer. We want to say, look, is that still applicable? Is it still valid? Is it still credible? And in order to answer these questions, we need data. Now, this could be primary data or secondary data. So we have a question. We want to ask whether this question is still relevant and pertinent. Is it credible? And in order to challenge or move beyond where we are, linkage and partnership, we'll be looking at how do we jointly conduct research. Now, people often say that, oh, we are the smaller partner in this kind of relationship. We are not as resourced as European universities, but that's not quite the case. We also have something that the rest of the world wants. We are blessed with natural resources. We are blessed with a huge young population. So all these things are things that will appeal to potential partners, potential universities. Universities in Europe and elsewhere are seeking for credible partners, credible university that they could work together. Now, some of the funding that comes to European universities is actually based on these universities having partners in developing countries. It's something that they cannot access funds from their home governments if they cannot establish partnership. So with this kind of condition, they actually need African universities more than we need them in a way. Now, funding for knowledge and CTP, we may have the best ideas in the world, the best technologies to share with others, but then we need funding, we need finance, we need resources to be able to do the work we are seeking to do. Now, in Nigeria, there is a federal government agency that is with the brief of providing funding for people from the academia to go for development, personal development, i.e. they fund the research. Now, my understanding is Tech Fund has technically no limit on funding the research, provided you have a very credible research. So in Nigeria, Tech Fund are the main government agency that will fund research that colleagues in the university are doing. So this is the first point of call. Again, of course, you have to get the approval of your management, leadership of your university. You met all the criteria of getting partners, getting research. Now, in my own personal experience, I have brought, I would say about 70 colleagues from universities across Nigeria to Europe to work on knowledge and technology transfer. And all of them, without exception, were funded by Tech Fund. So Tech Fund steps in to pay for bench fees, they pay for travel and subsistence for you to travel to your partner in Europe or elsewhere. So in Nigeria, we are fortunate to have Tech Fund to be able to finance.
Thank you. Just one comment from Engineer Dr. Aloha Omorige, please.
Hello, can you hear me?
I can hear you, sir. Yes.
Yeah. See, when we interact with our colleagues in Nigeria, there is always this saying that there are insufficient funds. So because of lack of funding, there is no research. No research as to, is this sufficient factor? Is this the sufficient reason not to engage in research? Because research by itself, by its nature, is something that we do, whether we like it or not, we would.
Problems we're looking at. How do we increase productivity without compromising safety? So what we did, that was me there a couple of years ago now, with very freezing cold conditions in the UK. I think it was about -6 degrees out in the countryside, so it was extremely cold. Working with a number of machines and manufacturers, we created a test application where we had a machine. That machine used GPS and GIS, so it could understand, and also the position in relation to the surrounding environment. We had smart sensors fitted to the rear axles of the machine, so we could sense how that load was being transferred from the front to the back to give that instability that we were looking at there. We connected that to a satellite Internet of Things option. That was then beamed down to our server, and on that server we were running big data, and also we were running computational intelligence algorithms to basically monitor the performance of the vehicle in real life. From that data, we observed that the cutoff switch for the safe load indicator on the machine was actually adding to the instability, because the safe load indicator couldn't differentiate between the machine traveling on level ground when compared to a machine traveling with a load. And so if we could disable that technology and focus on how that center of gravity moves to the back of the machine, we were able to devise a machine that didn't cut out the hydraulics when needed, in other words, to try and prevent an overturn, but we're able to use that hydraulic power to generate greater performance in the machine overall. Now, if BIM to the machine, that's what we've tried to do here. Now, BIM has been blown out of all proportion, in my humble opinion. It isn't just a piece of software, but when you link BIM with Industry 4.0, it becomes a very, very exciting proposition, and that's what we've tried to do in this research. Now, that looks horrendously complex as a data flow to understand from the customer on the top left-hand corner there, through to information exchange, through to estimation, information exchange, CAD development, and so on. We had to identify where that order flowed through, and also who was responsible, who was the gatekeeper at each of those processes. Once we mapped those processes, we were then in a better position to create a relational database. That relational database could then link up all of the information in the process. And once we'd created that relational database as a back-end system, we're then able to look at the swim lanes in production. So from the initial conceptualization and preparation, we could tie BIM and sensors and databases and algorithms and augmented reality into a final product, so that the customer could order the product, they could view the product, they could approve the product, and then take that product right the way through to the factory, literally at the click of a button. I was supposed to say bigger, do apologise. It was very early this morning when I typed this in. Multidisciplinary teams is the way to go. I'm a firm believer of that. I think we have to break down the barriers of people thinking that they're an engineer or a construction man or a manufacturing guy or nuclear physicist. For me, a research problem is a research problem, and there's great commonalities in research problems that require different speciality knowledges from. So I would say construction, civil engineering, original equipment manufacturers, engineers, and professional bodies should be working together on one side. And on the other side, we have to include people from IT, artificial intelligence, cybercrime, hardware engineers, people to work effectively in those far bigger teams.
And all that around it, or all that was put aside when their budget was exceeded. So that's what it is today. The little building at the bottom is newer. That was finished just last year. It's a set of, again, very simple looking building, which is a set of 12 houses that are all together in a place called Northampton here in England. And what's unique about this? Again, ground conditions. This place was built on an old site that was bombed during the Second World War. That's another thing you find here in the country. We still find relics of bombs and things and bunkers that were built during the Second World War on some sites. And we have to find ways to build around it because you don't know the extent to which it exists, and you cannot start, digging up everything every time. So this site was one of those that had one of those basement bunkers. And the only way we could do was to make sure that we put it on piles as well and went around everyone. And so we made sure we bypassed the layer where those things were sitting. And then we had a system of ring beams that was put on top. And these are some of these are all new builds. And so I just put that in to say I don't completely only get involved with refurbishment, but I find that there are unique challenges with refurbishment projects. Very unique. Very, very unique, and I'm going to talk about them very quickly, as quickly as I can. The first thing is that there are design issues. There are design issues with refurbishment projects. There are too many variables. Design of any kind is faced with variables anyway. Loading variables, things that you have to determine. Exposure to wind, and so many other things that you have to deal with. Like I've been talking about ground conditions. So, but when you come to refurbishment projects, you are dealing with buildings that exist, and also you have to deal with them in terms of what work needs to be done. In this country, for example, at times we build upwards, that is, we increase the height of the building with a couple of floors, and at times we include basements, we're building new basements, which means we basically undermine an existing structure and put in a new living space beneath that structure. This is a very common practice now in London. As you know, the price of land in London is so high. So most premises, especially residential premises, are having some kind of modifications to make them larger and to grow up or come down. And so there are a lot of design issues involved. Also construction issues. We're talking about existing sites, very usually constrained. So you don't have the luxury of a big expanse of land where you can store materials and things. So you have to use things like just in time, where you drop beams and things that you need to use on site and put them in. And these are part of how we research, looking at processes that help us to deliver. So we study these things as part of our research activity. We have students and people who work on these things and study these processes and look at how best to improve them, so that we actually test them on live projects. And this is one of the areas I'm going to talk about in terms of this integration I'm referring to. And then we have issues with existing structural integrity. How strong is a building built in 1920? How do you know? Who knows? The drawings you may find are on some kind of paper that's faded away, and you are not even too sure whether that was accurate or not. So many times there is no record. You have to use a lot of subjective judgment. And so what we have been doing is that from project to project, we are documenting experience so that we can have a more robust database, because now everything is, as we all know, is going digital. We have our very fancy software that generate frames for us, and do all the calculations. When we're doing new builds, they're so beautiful to watch, and they do all your frame analysis and, you know, just give you your specs and you're gone. You can't do that in a refurbishment. You can't, because you have no idea what materials exist. You are trying to mix old with new, new with the old. You are trying to knock out some of the old and bring in new, and you want there to be an integration. It is a very different, very, very different ball game altogether. And then there are procurement issues. Not every engineer, not every contractor has competence in this kind of project. As a matter of fact, I know professionals in this country that would not do anything that is not new build. And it's not because it's not because they can't, it's just because they don't want to be involved with the risks and there's so many things that go with it. And then that goes with project management issues as well. You need very good project managers, like I said, those that know how to plan projects very well to accommodate all these variables that are restricting the site work. And then you have aspects of
I think there are emerging technologies that are going to be even more disruptive, which again, I would say in post-COVID times, we want to take a look at. And indeed, talking about COVID itself is a very interesting study. What we do know is that the Bill and Melinda Gates Foundation, because of the work they had been doing with Nigerian schools of medicine and indeed medical facility, they were able to actually reference the whole of Nigeria. This was done originally for eradication of polio, which, as you would have heard 2 days ago, has now finally been eradicated throughout Nigeria, but also in terms of the tracing and tracking related to the Ebola pandemic in Liberia / Sierra Leone. With the use of, again, mobile phones, they were able to actually basically geolocate all of us in Nigeria. The geolocation of Nigeria is complete. So it's not just GIS, you've got geolocation and mapping. This means that, this meant that at the height of the Ebola epidemic, if you had Ebola and you were identified as having it, you could be tracked. And that, to a large extent, was able to stop the flow of Ebola from Liberia across to places like Nigeria. So in some ways, again, given, as we do know now, the politics of what's going on now, some of that tracing and tracking that we're talking about, we already have a lot of ability and both the technology and the knowledge to carry it out successfully. I would suggest that if you don't do it already, the World Service has a regular broadcast called Africa in Focus, or Focus on Africa. There was a very, very clear description from a Liberian doctor about how they do trace and track in Liberia. And to be honest, it would put certain governments, which shall remain nameless, to shame in the straightforward way in which it was being undertaken and how the community was involved and so on and so forth. So this is again the issue about the technology, especially when it's available, is something that does not necessarily have a location that is north-south. Often it's taking both the ideas and then sometimes applying those ideas to particular situations. And I would say in the case of West Africa, particularly nowadays, there seems to be a push towards thinking further outside the box. Having said so, there are still massive problems. We do know that testing or rather, it's not the testing now, it's more, the track and trace works very well, but issues around how we can guarantee the testing and whether we have enough of the facilities in terms of ventilators and so on is still a problem. But some of the very basic problems, which I do think are actually technological and engineering focused, are things that we are quite able to work on and develop in a very successful fashion. So the idea, I guess the thesis I'm coming through with here is that it is important that we are able to utilize our understanding of these technologies, and by applying them, we can actually begin to think outside what I would call the standard box, which is, oh, well, we wait for the information to come from the north and then we apply it. Oftentimes, if we have the raw material, so to speak, we can actually begin to look at what is most appropriate and what actually, in some ways, better responds to our requirements in I would say particularly Africa. How do we incorporate these practices? Well, I think part of it is that we're looking both at the history of the past, but also we're looking to the future. So in no way am I saying that, you know, when we're looking at thinking about technologies, we have to go right back to the historic and the cultural. Nobody's saying we have to go back to living in mud huts or anything like that. But what we are saying, or what I am saying, is that when we're looking at technology, we can actually begin to, I would say, both embrace it, but also create from it what is relevant to our needs. So at the top end, of course, we have our Starchitects. At the top is a concept shopping centre by Sir David Ajayi, the architect. And at the bottom is the EcoBank headquarters, which is again by a Ghanaian architect, which has used, I guess, much more of the bottom particularly is using much more in standard, I guess, modern materials. But the conceptualization of the circle has the map of Africa on it, and it's oriented towards the north. So it's got this whole narrative around how it relates to its space in Ghana, which, as you might remember, is seen as a center of Africa because of its Pan-African credentials and so on. Whereas David Ajayi's building on the upper level is using things like micro-cut wooden slats to, again, respond to the requirements for shading and so on and so forth. So in both these cases, there's been an embrace, I would say, of much more modern technologies, but it's been very much adopted and adapted to what might be relevant for Africa today.
Good evening, everybody, distinguished member of the most honorable profession on the planet of the arts. Engineering is a journey that is worth celebrating. By the time I finish my presentation, we'll be able to see what an engineer in Nigeria, what a black man is capable of doing to address their own people. Authority there, that look, we don't want this kind of, because it's a change to them. We don't want prepaid. We are used to collecting recollection fees from consumers. We don't want prepaid. It's not meant for us. I said meant for us because that is the only way we can guarantee sustainability. By and large, few number of idealistic engineers. This is the kind of meter I use for the pilot. This is Conlock. Practically, I was representing, though it looks new to them, but it's a welcome development. For one single reason, nobody comes to their premises to harass them any longer, to say we want to read your meter, because it's an abuse of the system. Because at times you just get some, people even pretended to be a NEPA personnel to come and read meter, and before then, you can get something else. They start harassing you, and the armed robber even disguising the pretense of reading meter. So it's, to the elite, is a welcome development. That, look, I want to pay for what I use and I can control my consumption. It was a welcome development. So we tried the pilot for acceptability, sustainability, workability, and operability of the entire concept. It was a welcome development, even if those who are benefiting from the anomalies of the system of old dispensation kick against it. But the elites among them, the engineers, the technocrats at that point in time said, look, this is no data for us to even plan. So enumeration exercise has to be conducted one after the other, the discos, so that we can get a data in which we can work on. What is the metering gap? We don't have the record. What is the consumer base of the entire sector? We don't have record. There are so many duplication of data in the existing billing platform, which is Spectrum, which is DOS-based application, command-based application. Nobody is ready to upgrade that application. These are issues that actually makes our revenue collection nosediving. So quite a number of revenue are actually going to a private pocket, which is a concern for the sector to grow. 70 million. Why do we have to go to South Africa all the time to go and leverage on their technology. I put it across myself that I need to train young buyers, including my goods. We have to design our own management and vending platform. And today is a good news. About 5 or 6 discos are using our management platform, fully built Nigerian design, and we are the first Nigerian company to tender our design to the committee of STS and got certification at once without any correction. That shows how committed we are to develop our capabilities. The disadvantage of all these inadequacies in policy or policy somersaulting is that it kills morale of investors, because some of us has already invested so much in bringing in meter at that point in time. And what type of meter we brought was specifically tailored to address the need. Now the new owner of the disco came up and said, no, we don't want those meters. So we have to find a way to retrofitting. We should not allow our engineer to finish from their school and go and work in the bank. There is sufficient resources for us to be able to fly back home. So I will enjoy everybody in overseas to come back home, and let's make our country proud in terms of setting up any form of engineering infrastructure that will propel this huge capital must not go elsewhere. We have the intellectual, it's just to harmonize it and put it and make sure that our product is competitive. This is part of the dilemma of Nigerian engineers and professionals in the country. The Nigerian Society of Engineers, the body of current and all other agencies that is supervising engineering staff has a task to do. The whole task to do is to make our position felt by the policy line. It should be in line to develop local capability. We have what it takes, we have the idea, but it must transform to a product or services that would address our own peculiarity. Our peculiarities are quite different. I used to say to a lot of people that you can't compare Wall Street and Idumota. The approach is quite different. The templates are quite different. So our own problem can be resolved by ourselves if we put all heads together to address it. So the body of engineer, which is paramount for development, still need a lot of effort in interfacing with the government to ensure that whatever that is required to develop engineering infrastructure and company related to engineering should be sustained by whatever it requires. We should not keep quiet. And since luckily we have the president in the cabinet's voice now, he has to do more to ensure that what makes Volkswagen to die should not repeat himself. What makes textile industry to die should not repeat itself. This is the fourth industrial revolution. We should key into it and make sure Nigeria is part of the development that is coming globally. Other this could still be importing an application when Nigerian company is designing an application. Today, there is a policy change. There is a service-based tariff, which require you to change the tariff table. We are the first Nigeria to go into some disco using us, and we have changed to comply with the new structure. Every other person will start calling China, start calling South Africa. When we have the capability there, this is part of the responsibility of the body of engineers to ensure that as much as possible, local content is strengthened. We need to strengthen to ensure that the first point of call for any solution or for any challenges facing us as a nation should be homegrown solution so that we can support it. Most of the meter that are imported doesn't have support. Today, I'm glad to tell you that any of our meter that is retrieved from the feed, we can retrofit it, we can change it, we can turn it to new because it's our design. It's all our intellectual property and we have the patent for it. These are things that is good in supporting homegrown. This is part of our research and development team. They are all great Nigerian. We don't have one single foreigner in our team any longer. Because when I was trying to globalize it, I discovered that there's still politics when it comes to technology transfer. The people right there doesn't want you here. So you need to fight it because however, we can use it to build our own so that at any point in time, there can be user conferencing, technical conference, where we see down that what is the next level of our development. These are consultations that I believe either Nigerian Society of Engineers, body of all engineers should be calling for all people who are the industry, both technocrats, the scholars, and everybody, harmonization of all these things to say, what do we do for our country? Because we have the knowledge, but the knowledge must be shown. We must be able to prove it. Not that we keep going into theory and so many other things that doesn't make us to look fine in the rest of the world. We must be able to show the world that we have what it takes to develop our. I said we must look into the failure of yesterday in order to sustain the tomorrow we want to build. And the timing.
Okay. So, but cut long story short, I lost contact. My network, my line went off. This is one of the things we are facing in Nigeria. I'm in the office. My light went off. You are enjoying there. No light, no nothing. And now Kola Balogun is putting me under pressure. Look at the problem of books. Look at the problem we are having. So if we fight now, if we say we are too aggressive, how can we be aggressive? How can we fight? Tell me the two reasons why I will not fight. Tell me. We are on a system now. All of us are on a system. We are talking to ourselves. My light went off. Your own lights are there. And you tell me that I should not be aggressive. I should not fight. Why should I not fight?
All right. Discipline of them, Mr. President.
Thank you, sir. Thank you, sir. They don't know what we are passing through. They are there shining like under 18. Where we are here struggling with only light. Only light here. We are struggling with only light. Only one. The others, traffic will not allow you. No money will not allow you. This will not allow you. So many things we are facing. People are there just looking like 18, under 18. Oh, look at your head. You're shining like under 18. Where we are suffering here. I better go. But I appreciate Kola Balogun for his time. Kola Balogun, I'm just joking. I'm just joking with you.
Thank you, sir.
As a normal thing, nothing hard. But our prayer is you succeed. That's our prayer. On a very serious note, our prayer is for you to succeed. And we will never relent in promoting you. We will never relent in that. Even the that I am, once something on metering is mentioned, be rest assured that even if you are not visiting me, be rest assured I will stand for you. Because I know you, Momat is there. I will stand for you and I will talk for you. Even your absence, don't worry.
At the final end, you need electronics. And when you need to produce electronics, you come to the biggest electronic supplier in the market, the biggest supplier for production equipment to produce electronics in the market, and that's us. We have, on a global base, 10 R&D centers. We have 12 manufacturing sites. We have roughly 2,000 people working in R&D, and we are roughly holding 1,400 patents. And there you can see that's really a global setup. We have facilities in Boston, in Weymouth, England, in Porto, Portugal, in Netherlands, in Munich, in Regensburg, in Chengdu, in Johor, in Malaysia, in Fuyong, China, Waichao, China, Longgang, China. You see a lot of Chinese facilities, also Toyuan, China, and education with Taiwan. And then we also have Hong Kong, and at the final end, last but not least, our headquarters in Singapore from our mother company. And there you can see that we are really overall.
Why there is no presence in Africa or a place like Nigeria, talking about a global company like yourself and trying to list where you have presence. And I was wondering why there was none in Africa or in Nigeria in particular. That is one. Comment or question number two. Is there a trade-off between standards and innovation? Okay, because you talked about standards being a challenge that you are currently addressing. So I wonder what your thoughts will be around if standardizing processes stifles innovation or encourages innovation? That is question or comment number 2.
Should I answer or at the final end? Because first, why are we not in Nigeria or why we are not in Africa? We have customers in Africa, but not too many. The main area is northern part of Africa, where we have customers in Tunisia, in Morocco, and we also have in South Africa customers, but not necessarily in Nigeria, not that I'm aware of. Why is it like this? I personally believe that when you look into the overall electronics industry, then almost everything is on the northern part of the globe. There is some on the southern part in Brazil, in that area, in Mexico maybe, but the rest is actually mainly in China. Almost 50%, 60% of all the electronics production are in China, or in, I call it always, rest of Asia and the other Asian countries. Then there's about 20% in Europe. There's about 10% in the US. So here you can see that the production sites, at least our customers, are more basically spread on this northern part of the globe. So that's one reason why we are not so present in Africa. Yeah.
Thank you very much, Gunther, for that. Today, I can tell you that we would like to have you in Nigeria. Okay, so anything you need to be present in Nigeria, because we are a major consumer. And if we need to turn the fortunes of a place like Nigeria, then we need to have such excellent companies like yourself to be present. So anything you think you need, and it is something we can help engineer through this forum, please.
Yeah.
Yes, please.
Yeah, I guess it's not a question standardization or innovation. I guess innovation and standardization is something which builds to each other. If you have some kind of very great idea and you have a unique selling point, then usually there is a way how certain kind of new ideas and new technology is developing, and there's a curve behind. It's going up all the way. You can really utilize because you're the only one in the market who can deliver. So that's happened to us in the 90s. We have been the only ones who designed machines like we have today. Okay. Then our Japanese competition copied us significantly. Okay. So now when you go to a show, all the machines look very similar. So the question is, how much can you differentiate? And with the machine itself, you cannot so much differentiate anymore. Don't get me wrong. Also, our Japanese competitors have good machines. They copied good and they improved. And we also have to work on that. So that means we are a little bit more, we call it, and it's also considered in the market as the innovation driver for this kind of market. But at the final end, an innovation today is going to be standard tomorrow. Okay. So that means when you look into our equipment today, then you think, oh my goodness, 90,000 or whatever. Yeah. But in 5 years, that's normal.
Why do we need to study renewable energy systems as an alternative to fossil fuels? So according to the International Energy Agency, that's the IEA, 1.1 billion people do not have access to electricity. And 97% of those live in sub-Saharan Africa and developing Asia. So currently at the moment in 2020, we still have 600 million Africans that live in total darkness. And when we talk about not having access to electricity, there's a difference between energy access and energy poverty. Currently, we do have lots of us are connected to the Nigerian grid, but we are experiencing energy poverty, going days without electricity. But even because we are connected to the grid, we're not included in this 600 million people. So you can imagine having 600 million people not even connected to any source of electricity. No matter, don't have any access. So you can imagine how life happens for them. So if you look at the graph over here on the right, this is it's showing briefly the world population without electricity access. And as you can see, Nigeria is one of the largest contributors. That's on a country level. Currently, there are over 600 million, as we can see, just about 620, and it is projected to increase further within the next 5 years. Unless we do incorporate some form of renewable energy, or we come up with a viable or sustainable option, this is going to increase further, and we're going to move more and more into an energy crisis. So the conventional solution to this is generating power from thermal and hydroelectric power stations. They are the most common, but of course we have nuclear power stations, which over here, that's not much of an option because of the sources and the difficulty in handling the radioactive components. So basically, our major options, the largest contributors are thermal and hydropower stations. However, when you talk about a thermal power station, they do generate lots of, they have lots of emissions, harmful gases. There's carbon dioxide, there's nitrogen oxide, there's sulfur dioxide. All of these lead to the pollution of the environment and have had harmful and devastating effects to our health. So because of this reason, you cannot situate a thermal station close to the load centers where people are. You need to put it in remote locations. Additionally, the hydropower stations, you can't bring them close to us because you need them to be close to a waterhead. So because of these two power stations, even though they are a good solution, not for the environment, of course, but they lead to large investments in power transmission equipment. So the best solution is going for distributed generation, and distributed generation simply means generating power where you need it. And in order to get the most cost-effective and environmentally friendly alternative is generating the energy from distributed sources by using renewable energy sources. And the two major advantages are the reduced greenhouse gas emissions, and as well as the reduced costs, because we don't need to transmit power over long distances again. Now, according to research, biomass alone, which is a renewable energy source, can supply 26% of the world's energy consumption, and that's just biomass. And the global renewable energy capacity is set to increase to 1.2 terawatts, increase by 50%, that is, to 1.2 terawatts in 2024. And of this growth, this exponential growth we're seeing, 60% is coming from solar PVs, and almost half of that are rooftop solar PVs that we put on residential settings or small commercial settings. So this is a very important reason why we need to be investing our time and energy to R&D and incorporating these renewable energy sources, particularly solar, into our environment. And solar PVs are, of course, on track to meeting the sustainable development scenario, which is generating clean and affordable energy by using renewable energy sources such as solar in order to reduce the harmful effect of climate change, as well as increasing the quality of the air we breathe. That's 3 SDGs there: SDG 7, SDG 13, and SDG 3, just by using solar PV systems. So this is a graph which shows us an overview where you can clearly see that between the year 1990 and 2018, the annual growth rate, that's the average growth rate that happened over these years. And you can see that solar photovoltaics are the largest, followed by wind, and then you have others such as solar thermal and liquid biofuels. So of course, this is also another reason why we should be investing our time to look into this solar alternative, especially for sub-Saharan African countries.